Hi young friends, welcome back to C level physics. In this video we are going to discuss some numericals related to resultant simple harmonic motion. So in this type of questions you will be given equations representing some simple harmonic motions. When particle is reached by these vibrations simultaneously, how it behaves? What is the expression for resultant simple harmonic motion? Let us see. This is what? Model number 2. Second model, to find equation of resultant SHM. To find equation of resultant SHM. Okay, right? So first question, x1 equal to 3 sin omega t plus 30 and x2 equal to 4 sin omega t plus 120. So these are the expressions for two individual simple harmonic oscillations. When particle is reached by these expressions, these vibrations simultaneously, then what is the expression for resultant oscillation of the particle? That's what we need to find, resultant expression. So here, question number one, solution. See, what is the amplitude in x1? 3 is the amplitude. What is the amplitude in x2? 4 is the amplitude. Now omega t plus 30 is the total phase of first expression. Omega t plus 120 is the total phase of second expression. So pi 1 equal to what? Pi 1 omega t plus 30. Pi 2 means what? Omega t plus 120. Omega t plus 120. Now what is the phase difference between these two oscillations? That is delta pi equal to pi 2 minus pi 1. Why? Because pi 2 is greater than pi 1. So pi 2 minus pi 1, that is omega t plus 120 minus of omega t plus 30. Omega t plus 30, that is omega t cancel, 120 minus 30, that is delta pi equal to 120 minus 30 means 90 degrees. So these two differ in phase by 90 degrees. 90 degrees. So we have to consider one reference axis. See, this is what reference axis. Say x-axis, reference, right? Reference. See, this is what reference axis. Now at t equal 0, what is the initial phase of first oscillation? That is 30 degrees. So 30 degrees. This is what A1. As far as first oscillation is concerned, its amplitude A1 equal 4. A1 equal 4 can be taken like this. Now what is the phase here at t equal 0? 30 degrees. So this amplitude making 30 degrees with reference axis. So 30. Now what about the amplitude of other oscillation? That is 4. What is the initial phase at t equal 0? 120 is the initial phase. So with respect to reference, A2 makes an angle 120. 120. A2 equal to what? 4. That is 120 degrees. What is the phase here? 120. 120 degrees. Now what is the phase difference between these two? A1 and A2. That's what? 90 degrees. Between A1 and A2, delta pi equal to 90 degrees. So this is what? 90 degrees. Phase difference between A1 and A2, that is first and second oscillations differ by a phase change of 90 degrees. Right? Okay. Now, how to find resultant amplitude? See, these two are inclined at an angle 90. Therefore, resultant amplitude, say A is the resultant, amplitude. Resultant amplitude. Now, as far as parallelogram law of addition is concerned, resultant A is given by A equal to root over A1 square plus A2 square plus 2A1 A2 cos pi. 2A1 A2 cos pi. Right? Or cos theta. Right? That is what cos theta, for example, theta. Now A can be written as A1 square plus A2. A1 square means 4 square plus A2 square means, A1 equal to 3, A2 equal to 4. So A1 equal to 3, that is 3 square plus A2 4, that is 4 square plus 2 into 3 into 4 into cos 90 degrees. These two differ by 90. So therefore A1 A2 are inclined at an angle 90. Cos 90 is 0. That is 3 square plus 4 square. 3 square plus 4 square. That is 5. So resultant amplitude A equal to 5 centimeters, for example. In CJ centimeter, in SI meters. So A equal to 5. We have A, value of A, resultant amplitude of the resultant SHM. Now, these two are inclined at an angle 90. Now, resultant of these two make some angle with A1, for example. See, this is what resultant. For example, this is what resultant A, right? If I close parallelogram parallel to this one side, and parallel to A1, one more side. So parallelogram is constructed. Now what is the angle made by resultant amplitude with one of the amplitude A1? Say that is what pi. Pi means what? Angle made by resultant with one of the parent vector, say A1, that is 3. So we know that tan pi equal to right, tan pi equal to opposite side by adjacent side. What is opposite side? 4. What is adjacent side? 3. So opposite side A2 by adjacent side A1. That is A2 means what? 4. So opposite side. See this right angle triangle, tan pi opposite side by adjacent. Opposite means what? 4. Adjacent means 3. So 4 by 3. That is implies tan pi equal 4 by 3. Pi equal tan inverse 4 by 3. That is pi equal 53 degrees. Pi equal to 53 degrees. 53 degrees. So we have value of resultant amplitude as well as angle made by the resultant amplitude with A1. So pi, the direction of resultant amplitude. So what is the general expression for simple harmonic motion? That is, so some x equal to resultant expression for the SHM. X equal to A sin omega t plus, see here, with respect to reference axis. See this is what reference axis, say x axis. With respect to reference axis, this amplitude of resultant oscillation makes an angle 30 plus pi. See here, 30 plus pi, right? See, this is the reference axis. Now A, resultant amplitude makes an angle 30 plus pi. So that's what omega t plus pi is the resultant expression. So x equal, therefore x equal to replace A with 5 sin omega t plus pi means what? 53 degrees. 53 degrees. So this is what ultimate expression for resulting equation, resulting simple harmonic equation. So whenever the particle is reached by these two oscillations simultaneously with so and so initial phases, then that particle oscillates with a net amplitude 5 centimeters and initial phase 53 degrees as shown, right? This is what 53 degrees. That's what first sum. Now coming to second one, see here we have three oscillations, x1 equals so and so, x2 equals so and so, and x3 is so and so. See in x1 amplitude a1 equal to, in x2 a2 equal to 2 root 2, in x3 a3 equal to 1. Right, here initial phase when t equal to 0, what is phase here? Omega into 0, that is 0. Pi 1 equal to 0. Here when t equal to 0, what is initial phase? 0 plus pi by 4, that is pi by 4. Pi 2 equal to pi by 4. Coming to third one, when t equal to 0, we left with pi by 2. So pi 1 equal to 0, pi 2 equal to pi by 4, and pi 3 equal to pi by 2. These are the initial phases. Now coming to question number 2. Now pi 1 omega t, pi 2 omega t plus pi by 4, pi 3 omega t plus pi by 2, like that. Now in this case also have to specify the expression of resultant SHM. When particle is reached by all these oscillations simultaneously, how it behaves simple harmonically with amplitude and phase. Let us examine, right? Okay. When t equals 0, see here, when t equals 0, means at initial instant. What is angle here? Omega into 0, 0. So pi 1 equal to what? 0. Pi 2 means what? 0 plus pi by 4. So pi 2 equal to pi by 4. Similarly, pi 3 equal to what? 0 plus pi by 2. That is pi 3 equal to pi by 2. Right? Pi 3 equal to pi by 2. Now, the amplitudes, individual amplitudes should be represented vectorially in specified directions with respect to reference axis. Now say this is what reference line, see reference line. Okay. So with respect to reference line, what is the angle initial phase of first oscillation? 0 means A1 can be taken along the same way. A1 equal to what? 2. Right? This is what reference line. Right? With respect to reference line, what is the angle made by second oscillation? Phase of second oscillation? Pi by 4. See, like this. Pi by 4. This is what A2. So amplitude of second oscillation can be taken as 2 root 2. That is A2 equal to root 2 to root 2. What is the angle made by this amplitude with reference line? That is when t equal to 0, pi by 4. So this is what? Pi by 4. Pi by 4. That is 45 degrees. Next one. Coming to third one. What is the amplitude here? A3 equal to 1. But at initial phase when t equal to 0, pi by 2. So pi by 2 with respect to reference line, not with respect to A2. Right? With respect to reference line, pi by 2 means take along y-axis like this. So this is what? A3 with value 1. 1. So A3 makes an angle pi by 2 with reference line. Right? Now same can be written as like this. See here A1 equal along x, so A3 is along y, but A2 is in the plane, so it can be resolved into two components. So like this. Along x, already we have 2 plus, what is the component of 2 root along x? 2 root 2 cos pi by 4. 2 root 2 cos pi by 4. Right? Similarly, we have A3 equal 1 along y. 1. Already we have 1. 1 plus, what is the component of 2 root along y? That is, this is pi by 4. Now, what about this value? 2 root 2 sine pi by 4. 2 root 2 sine pi by 4. Right? Okay. A2 here. A2 means 2. 2 plus 2 root 2 cos pi by 4. Similarly, A1, that is 1 plus 2 root 2 sine pi by 4. Component of A2 along y-axis. Now, ultimately, this is what Rx and Ry. This is what Ry. This is what Rx. R means what? Resultant amplitude. For example, let R be the resultant amplitude. R be the resultant amplitude. Am I right? Let R be the resultant amplitude. Now Rx means what? So Rx equal to 2 plus 2 root 2 into cos pi by 4. 1 by root 2. Right? So that's what root to root cancel. We left with 4. Similarly, Ry equal to Ry. 1 plus 2 root 2 sine pi by 4. 1 plus 2 root 2 sine pi by 4 means what? Again 1 by root 2. Root 2 cancel. We left with 1 plus 2, that is 3. So Rx means like this. Rx equal to 3. Ry equal to 4. Now where is the resultant of these two? Lies in between. So that's what resultant R. If I close like this, so these two are taken as the adjacent sides of parallelogram. Right? Try to close the parallelogram parallel to Ry one side, parallel to Rx one more side. Now diagonal passing through the intersection is the resultant of the Rx and Ry. So R equal root over Rx square plus Ry square. Now what is the angle made by R with Rx, that is say pi. Phase, angle made by resultant amplitude with one of the parent vector 3, that is pi. So here R can be written as root over Rx square plus Ry square. Rx square plus Ry square, that is Rx square means 3 square plus Ry square means 4 square. So what is R? That is 5, equal to 5. So 5 is the resultant amplitude of the resulting SHM. Now what is the phase of resultant amplitude with one of the parent vector Rx, that is tan pi. Take tan pi equal to Ry by Rx. Once again, Ry by Rx, that is Ry means what? 4 divided by Rx means what? 3. So pi equal to tan inverse 4 by 3 implies 53 degrees. Pi equal to 53 degrees. Now what is the general expression? Resulting expression. So resulting expression equal to x equal to a or otherwise r. Why? Because we took resultant as r. So replace a by writing r. R sin omega t. See here, what is the reference line here? X-axis. What is the direction of resultant amplitude with the reference line? Pi. So omega t plus r sin omega t plus pi. This is the general expression as far as given data, right? R sin omega t plus pi, right? So x equal to r means what? 5 sin of omega t plus pi means what? 53 degrees. 53 degrees. So that's how one can estimate the expression for resultant SHM in case of particle reached by more than one oscillation simultaneous, right? So that's about the second sum. Now coming to third one, we have two expressions here also. Three expressions: x1, x2, x3. Right? x1 equals so and so, x2 equals so and so, and x3 equals so and so. If particle comes to rest at mean position, find B and theta. See here, particle reached by all these oscillations simultaneously. Particle reached by all these three oscillations simultaneously. When it is reached by all these three oscillations, particle comes to rest at mean position. At mean position means x equal to 0. So on adding all these three expressions, x1 plus x2 plus x3, resultant is 0. Why? Because from data, particle comes to rest when it is reached by all these oscillations, right? So coming to third question. Question number 3. So from data it is clear that the resultant displacement means the displacement of particle on adding all these three displacements equal to 0. So the resultant displacement x equal to x1 plus x2 plus x3. From data it is 0. Why? Because particle comes to rest reached by all these oscillations. So 0 equal to x1 plus x2 plus x3. So we need to find x3, the value of b in terms of a. So for first and second oscillations, amplitude is a, but for coming to third oscillation, it is b. So we need to find the value of b in terms of a. So value of b means what? Amplitude of third oscillation. So x3 is unknown. x3 equal to minus of x1 plus x2. Minus of x1 plus x2, like that. x3 equal. So I'm taking modulus, mod x3 equal to mod of minus x1 plus x2. So in magnitude, x3 equal to x1 plus x2 only. x3 equal to x1 plus x2. But in direction, x1, the direction of x3 equal opposite to the direction of resultant of x1 and x2. So try to give directions to respect to amplitudes. that is for A in the first expression and again A in the second expression and B in third expression. See, the reference line, we have to select one reference line with respect to which we need to mention the direction of given amplitudes, respective amplitudes. See here, when t equal to 0 in first expression, t equal to 0, what is the phase? 0. So that's why I am taking one reference line like this. See, this what reference line. Reference line. So with respect to reference line, what is the initial phase at t equal to 0 for first oscillation and t equal to 0? Pi 1 equal to 0. So therefore, this what A1. A1 equal to A. First oscillation, number 1, A. Oscillation, amplitude A. Now coming to second one, see, when t equal to 0, what is the phase here? 2 pi by 3. So initially, the amplitude of second oscillation makes an angle 2 pi by 3 with reference line. 2 pi by 3, that's what 120 degrees, like this. 120. This is also A only. Second oscillation, 120 degrees. See, this is what 120 degrees. 120 degrees. Right. Now this is what x1, x2. Now what is x1 plus x2? Resultant of these two. That is opposite to x3. So try to draw one parallelogram by drawing one side parallel to A and one more side parallel to A. Parallel to this one. One side like this, one side as shown. Right? Parallel to this one more side like this. Right? Now these two are of same magnitude. See, here it is A, here also A. Angle is 120. Definitely resultant bisects. When two vectors of same magnitude are inclined, then resultant lies, means resultant bisects from the common point. So resultant bisects like this. So this is what x1 plus x2. x1 plus x2. What is the displacement of first oscillation? x1. What is the displacement of second oscillation? x2. Now this is what x1 plus x2. Otherwise, a bar plus a bar. A bar plus a bar. Right? Okay. Bisects means 60 degrees, 60 degrees. Why? Because we know that r equal to 2p cos theta by 2. When p equal to q, as per parallelogram of addition of vectors, when two vectors of same magnitude are inclined at some angle, then resultant is given by 2p cos theta by 2. 2p cos theta by 2. See here, 2 into p means what? A. P equal to q, that is p means A. Here also q means A, that is 2a into cos. What is the angle between these two? 120. 120 by 2. That is 2a into cos 60 means 1 by 2. That is A. Resultant is A. What is the resultant of these two? Again A. Again A. So in terms of displacements, x1 plus x2. In terms of amplitudes, A. This is what A. Resultant A. Right? Here, x3 equal to opposite to that of x1 plus x2. x1 plus x2 lies this way. Definitely, x3 lies opposite to x1 plus x2. Why? Because here negative sign is there between these two. Between x3 and x1 plus x2, we have a negative sign. So here x1 plus x2 directed this way. Definitely x3 directed opposite to this one. This is what x3 with amplitude what? Amplitude equal to b. Amplitude equal to b. Now by symmetry, these two are of same magnitude. See, I am taking modulus. These two are of same magnitude. x1 plus x2 as well as x3 having same magnitude. Same magnitude. So by symmetry, this is 120 degrees. Here also from here to there 120. Now what is angle ultimately? What is the total angle made by x3 with reference line? 120 plus 120. That is 2 pi by 3 plus 2 pi by 3. 4 pi by 3. That's what final phase of third oscillation with respect to reference line. With respect to reference line. So that is, of course, these two are of same magnitude. Therefore, what is the resultant amplitude here between these two? What is the resultant of these two? That is A. A. Here also x3 and x1 plus x2 also same magnitude. Therefore, Therefore, B also equal A. That equal to B also. So B equal A. So what is the expression for x3 here? Find B, value of B and theta. Value of B and theta. That is, value of B means therefore as mod x3 equal to mod of minus x1 plus x2. That is B equal to mod x3 means B equal to mod minus x1 plus x2 means A here. So B equal to A. B equal to A. So that is what B, value of B. Next, what is theta here? What is theta? Theta means what? Angle made by third oscillation with reference line. See, this is third oscillation, this is the reference line. What is the angle from here to there? That is 120 plus 120. So theta equal to 120 plus 120, that is 240 degrees. That is 4 pi by 3 radians. 4 pi by 3 radians. Okay. Now coming to next one. x1 equal 3 sin omega t and x2 equal 4 sin omega t plus pi by 2. This is a given question. Now we need to find expression for resultant oscillation. So resultant oscillation means x equal x1 plus x2. X equal to question number 4. Question number 3 completed. Question number 3 completed. Question number 4. Question number 4. Right. So x equal x1 plus x2. Here we have two individual SHMs reached by particle. One particle is reached by these two oscillations simultaneously. Now see, at t equal 0, what is the phase angle of first oscillation when t equal 0? Pi 1 equal 0. Pi 1 equal 0. Pi 2 equal what? Pi 2. When t equal 0, pi 2 equal 0 plus pi by 2. That is pi by 2. Pi by 2. Now take one reference line. Reference line like this, as usual. Reference line. So this is what reference line. Now when t equal 0, pi 1 equal 0 means A1 lies along reference line only. No phase angle. So therefore A1 equal what? A1 equal to 3. A1 equal to 3. Now at t equal 0, what is phase angle acquired by second oscillation? Pi by 2. So pi by 2 means take along y axis. So A2 equal to, what is A2? A2 equal 4. 4. Right? Pi by 2 degrees. Why? Because pi by 2 here. Pi by 2. 90 degrees. Now A1 equal 3, A2 equal 4. These two are inclined at an angle 90. Why? Because the phase difference between these two, delta pi. Delta pi equal to pi 2 minus pi 1. Pi 2 minus pi 1. Pi 2 means what? Total phase. What is total phase? Omega t plus pi by 2 minus omega t. Omega t plus pi by 2 minus total phase of second oscillation. Omega t plus pi by 2 minus total phase of first oscillation. Omega t minus of omega t. So omega t cancel, we left with pi by 2. So this is the phase difference of these two oscillations. So second oscillation ahead of first oscillation by a phase angle of pi by 2, right? Initially. Now, what is the expression for resultant oscillation? So if you want to express resultant oscillation, we need to find resultant amplitude. Now what is resultant amplitude? Like this, in between. So try to close to form one parallelogram. Parallel to A1 one side, parallel to A2 one more side. Now this is the diagonal, as usual. So A equal to, as per parallelogram, addition of vectors, otherwise triangle law, that is A equal root over A1 square plus A2 square. A1 square plus A2 square plus 2A1 A2 cos, what is the angle? Pi by 2. Cos pi by 2 0. That is A1 square means 3 square plus A2 square means 4 square plus cos pi by 2 0. So root over 3 square plus 4 square, that is root 25, that is 5. So A is the resultant amplitude of this combination is 5 centimeter, 5 meter, right? Now What is the phase? Let pi be the angle made by resultant amplitude with one of the parent vector A1. See, this is the resultant amplitude of resultant oscillation, which makes an angle pi with one of the parent vectors, say A1. So from diagram, tan pi equal to opposite side by adjacent side. What is opposite? A2 adjacent A1. So A2 by A1. A2 means what? 4. A1 means 3. 4 by 3 means pi equal to 53 degrees. Pi equal tan inverse 4 by 3 implies that pi equal to 53 degrees, right? So we have both A and phase angle. Resultant angle made by resultant amplitude with reference axis. So ultimately x equal to A sine of omega t plus pi is the final expression, valid expression, general valid expression. So therefore A means what? 5 sine omega t plus pi means what? 53 degrees. This is the required expression for resultant oscillation. Okay. Now coming to it, final sum, that is initially partly set x equal a by 2 and is moving in positive x direction, simple harmonically. Write equation of xt and vt. So apart from xt means apart from simple harmonic expression, resultant simple harmonic expression, we need to find expression for velocity also, means from which we have to differentiate with respect to time. Find what we will get in final expression, that will be differentiated with respect to time to get velocity, right? So question number 5. What is the initial position of the particle here? That is plus a by 2. Plus a by 2. Right? See, this is what x equal to 0 means mean position. This is what x equal to plus a means right extreme position. At t equal to 0, what is the position of the particle? A by 2. At t equal to 0, particle is at a by 2, plus a by 2, right? And is moving in positive x direction. What is the direction of motion here? Positive means velocity. See the direction of velocity. Of course, initially it is at half of the amplitude, but see the direction motion, it tends to move rightwards still. So that's what we came to know from data, right? So it is oscillating simple harmonically. Write equation of xt and vt. Write equation of xt and vt. How to find xt? X means what? This is what x, right? So take x equal to general expression a sine omega t plus pi, right? At t equal to 0, see the position a by 2, x equal to a by 2, substitute here, a by 2 equal to a into sine at t equal to 0 plus pi. That is 1 by 2 equal to a cancel, 1 by 2 equal to sine pi. Now sine pi equal to 1 by 2 in the sense we have two options, pi equal to, it may be 30 degrees, otherwise 90 plus 30. 90 plus 30, that is 120 degrees. 90 plus 30, 120 degrees, right? But which one is correct one here? Pi is at 30 or 120? How will you know? We have to consider precise correct option here. Even though we have two options, one only correct as per the given direction of motion. So if you want to get the correct option, we need to find expression for velocity also. See here. So therefore, x equal to, see general expression, replace here, x equal to a sine omega t plus pi. Pi means it may be 30 or 120. Which one is correct here? Let us check. Try to get right option, try to differentiate here. So v equal to dx by dt. What is v? What is velocity? The rate of change of position, that is dx by dt equal to a into sine of d by dt of a is constant, d by dt of sine omega t plus pi. That is V equal to A into sin omega t plus pi means cos omega t plus pi into one more time d by dt of omega t means omega. So ultimately A omega into cos omega t plus pi. Now see, particle is moving along positive x direction means V is positive. V is positive in the sense V greater than 0. V greater than 0. If particle moves in negative x direction, then V less than 0. If particle moves in positive x direction, V greater than 0. Implies that V greater than 0 implies that cos of omega t plus pi 0. That is cos of at t equal 0. See here, at t equal 0, V equal to A omega cos pi. It becomes A omega cos pi, right? A omega cos pi. Therefore, as V is greater than 0 implies that cos pi also greater than 0. Cos pi 0. Cos pi greater than 0 means pi must be less than 90. Implies that pi must be less than 90 degrees. See here, in these two options, 30 degrees is less than 90. If pi equal 120, definitely cos pi is not greater than 0. It is less than 0, which refers to particle enters in negative x direction. So, which is contradiction. So, therefore, right option is 30. So, go with 30 degrees. So, therefore, correct option equal to pi equal to 30 degrees is right choice. So, pi is 30 right, 120 is wrong. So, therefore, final expression, see here x equal to A sin omega t plus pi means what? 30 degrees is the variation of x with t, and velocity, see here v equal to A omega into cos of omega t plus pi means what? 30. So these are the valid expressions for both x and v. Okay friends, thank you for watching.